back. This puts us at part 6 of our semester 2 final review. Now, start on number 37. The instructions say condense the following logarithmic expressions and simplify. So, let's go ahead and write down the problem and I'll start explaining what's going on. You got log of 5x plus log of x. Now, when you have a sum of logs, so you've got a sum of logs, right? So when you have a sum of logs, you can use what is called the product property, or the product rule. And what that means is that if you've got two logs that have the same base, and you've got the log of something, right? You get two logs, same base, so they both have a base of a, and you're adding them together, you can condense them into a single log with that same base, where you multiply these two things together. So that'd be x, y. That is the product property. And that's what we're going to be using anytime you have a sum of logs and you want to condense. And there's a lot of reasons why you'd want to condense. The biggest one, for your sake, is that right now, if you wanted to solve for this x, you've got two separate x's all under different logs, or all inside different logs. And you don't want that. If they were all inside one log, then you could convert that one log and solve pretty easily. But with two logs, you're not looking too good. So we're going to go ahead and use this product property and write it as the same base, so log with the base of 10, right, common log, where you multiply these two things together. So you've got 5x times x. And so you've got a log of 5x squared. And that's it. You were done. That's the problem. 38. That was really anticlimactic. Alright, so 38. Log base 2 of 12x minus log base 2 of 2x. This is a difference of logs, whereas we had a sum of logs. There is also a property for if you have a difference of logs. And this is the quotient property. So, the quotient property says that if you have two logs being subtracted from each other, which we do, you can condense them into a single log. So we've got two logs with the same base, and they're being subtracted. Well, you can condense this into a single log where you take this piece divided by this piece. So it'll look something like this. Just like that. Log base a of x over y. Now, a big thing that I see students do is they think this is log base a of x over a log base a of y, creating two logs, one on top of the other. That is not condensing. The best thing to think about when you're doing this, in my opinion, is remember you are condensing the number of logs you have. You wrote down the word log twice here. You haven't condensed anything if you're writing down the word log twice again. Right? So this is what you have, not this one. Right? So we've got the difference of two logs, and we're going to condense that. It has the same base, which is 2, and you want to take this piece divided by this piece. And so you're going to have 12x over 2x. And you want to simplify this if possible because the instructions explicitly state to simplify. So 12 over 2 is 6, and x over x cancels, so it's log base 2 of 6. And that's it. Congratulations, you were done. Number 39. Wow, this is a pain. 2 times the natural log of 3x plus the natural log of 2x minus 2 times the natural log of 6x. This brings us to our third property, which is the power rule. Right? So for the power rule, if you've got some number in front of your log, you can move that power, or that number, excuse me, as an exponent to the value inside your log. So you'd have log base a of x to that power of whatever number is in front here. And again, the point of this is to put all of the terms or all of the numbers you possibly can inside the log so that when you convert, it will all exit the log. Right? You can't convert whenever there's a number in front of your log here. And also, another thing to point out, if there are numbers in front here, these properties don't work. So you'd have to use the power property before you can use these properties in situations where there's a number in front of these logs. So if you've got a sum of logs, but there's numbers in front, like we have right here, so we've got a sum of logs where there's a number in front right here. You can't use the product property until you've moved this number, and that's what we're doing in the power rule. So we've got two numbers here that need to be disposed of, moved around. So the 2 moves up as an exponent, and the 2 moves up as an exponent. And a lot of students, they write it out like this. They say that this is the natural log of 3x squared. That is not correct. You're supposed to take everything within the natural log and raise it to this power. So why would you just take the x and square it? You also need to take the 3 and square it. So we're going to go ahead and write it like this. Okay. So now you have a sum of logs. Here's your sum of logs. You can condense these sum of logs into a single log using the product property. So we're going to go ahead and do that. You've got the natural log of this piece times this piece. So this is where you need to have some decent algebra skills here. 3x squared, or quantity squared, times 2x. Now, before we move on to the next part, we're just going to go ahead and keep simplifying this. The natural log, this is 3 squared and x squared, so that is 9x squared times 2x. And that's within the log here. So now you take the 9 times the 2, it's 18, and then x squared times x is x to the third. So that is what these two terms simplify to. Now over here, you've still got this minus the natural log of 6x squared, quantity squared. So this is now a difference of logs, right? So you've got two logs being subtracted. So in this case, it creates a quotient where this term is on the top of the quotient and this term is on the bottom of the quotient. Right, top of the quotient, bottom of the quotient, right here. Right, so what we want to do is write this as the natural log of this 18x to the third, and then divided by 6x quantity squared. Right, that's what you're taking the natural log of. So we're going to go ahead and simplify that down some more, and that's going to get you the natural log of 18x to the third. Alright, I'll buy that that was not a 3. Alright, now here it's 6 squared x squared. So you've got 36x squared. Now this, again, can be simplified further. 18 over 36, if I'm not mistaken, is 1 over 2. And x to the third over x squared is x to the first on the top. Right, so this simplifies into 1 over 2. And if you write these out as x times x times x, and this is x times x, one of them cancels with one, another cancels with another, and you have one x remaining on the top. So that's the gist of how I simplify this in my head. So you've got 1x, or just x, over 2 inside your natural log. And there's your problem. There's your answer. Alright, I know these are a little more complicated, but really once you get the idea down, it's really not so bad. Number 40 comes next. Number 40 is 2 times the natural log of 3 minus the natural log of 5. So again, you've got a difference of logs here, but you can't use the quotient property until there are no numbers in front of your natural, or in front of your logs. And right now you've got this 2. So you need to use the power rule to move the 2 up as an exponent of the 3. So that's what we're going to do first. The natural log of 3 to the second minus the natural log of 5. And now we can go ahead and use the quotient property, where we've got the natural log of this over this. That's what we're going to do. So we've got the natural log of 9, that's what 3 squared is, over 5. 9 over 5 can't be simplified, those parentheses aren't necessary, but whatever. 9 over 5 cannot be simplified, so we are done. Alright, that was a pretty concise problem. Number 41. This will be the last problem in this section, and then we'll move on to 42 through 45. So, this is a complicated problem. We've got 0.5, I'm wondering if it was a mistake for me to put this on here, log of 4 plus 2 times the quantity log of 6 minus log of 2. No, I think you're good. I think we'll be fine. All right. So, we've not seen this before. This is interesting. We don't really know what to do. You could, like, if you think that you could take this and raise it to a power, you're sort of right, but really you're not. It might be right in your head, but the math is not going to work out. You can only move a number up to an exponent if it is right outside of a log. Then you could move it up. We don't have that. We have a product here. A product that has logs in it, sure, but it is a product. So this is just 2 times this thing. So we can't do that yet. What we can do, however, just like you would over here, so imagine you have this situation, right? Well, in our case it's minus. You can distribute that 2. Now 2x minus 2y. This is what we want to do. So you want to distribute the 2 in. That's what we'll do first. Actually, on that same step, we'll move the 0.5 up here. Alright. So now we've got this done. And again, what you want to do is, now if you look, we've got a number directly in front of a log. So now it can move up as an exponent. Up as an exponent. Now, 0.5 is 1/2. You will need to be able to see this if you want to simplify these problems down. This is more of a pre-AP problem, but I think it's good to see, especially on the review since I'm working it out with you. So I'm going to rewrite 0.5 as 1/2, and maybe you can see what it is that's going to happen here. So then I'm going to move the 2 up as an exponent. Log of 6 squared minus log of 2 squared. Now, we were already dealing with rational exponents before. 1/2 is, right, a power of 1 and a root of 2. So that is what it's going to be. So I'll rewrite this. Log of, it's a power of 1, so 4 is to the first power, and it's the root of 2, so that's a square root. And then here, this is 36, and this is 4. So now, when you're tackling these problems, you want to go left to right, right? You want to actually, the best strategy is to combine your sum of logs first. Any sum of logs you've got, combine those using the product property, and then do the quotient property with the subtraction, the differences. So the square root of 4 is just 2. So that's log of 2 plus log of 36 minus log of 4. So this, again, is a product property situation where you're summing two logs. So what do you think that would be? Well, you take single log, and it's this piece times this piece. Alright, so 36 times 2 is 71. Running out of space here. So we've got log of 71 minus log of 4. And now we're down to a difference of logs. And in a difference of logs, you can combine, condense into a single log, where it is this piece divided by, that is not a divided by sign, divided by this piece. So you've got 71 over 4. Congratulations. We are all winners of the converting log. Prize game? Who cares? Alright, next we've got, oh, that was it. Alright, so we are done with this part, and on the next part we'll start expanding logs. So this entire time we've been condensing. On the next part we'll be expanding. Thanks for joining me. And something I want to say is, to any of you students who are watching this, I really am proud of you. You are taking an initiative. You're like hours into this. Who knows? Like you're a long ways into this, and you're really showing some initiative to work the problems out and see how to do them, instead of, asking your friends and copying down answers and texting each other screenshots or whatever of your work or their work, right? This is the best way to do it, right? Learn it in such a way, or like see the problems done in such a way that you're actually learning the material. That is best. So to any of you who are watching this, I am genuinely proud of you, and hopefully you'll get this stuff down and it will show on the final. And if you are the type of student who is, or if you are exempt from my final, then, even more kudos to you that you're bothering to see this, and you don't even have to take my final. So, very good.